Welcome to The Explainer. Step inside the digital workshop. Today, we are launching into a full-scale grade makeover kitchen audit. We are slicing directly into the absolute heart of Cambridge AS and A-level mathematics, syllabus 9709. Specifically, we are tackling the exact topic that trips up thousands of candidates in every single examination series, topic 6.4, sampling and estimation. Listen, I am putting on my master auditor hat today because we are going to take an uncompromising, critically sharp look at exactly how examiners deconstruct your exam papers line by line. If you want to transform your mouthwork from a disorganized, undercooked mess of equations into a perfectly structured, top-tier Michelin star response, you are in the exact right place. Look, in my years of auditing these papers, I see two incredibly common archetypes of students in the exam kitchen. First, we have the apprentice I call Alex, the overcomplicator. Alex takes massive piles of raw, unanalyzed factual definitions, dumps them onto the page, and hopes the examiner will somehow sift through the mess to find a clear argument. It never happens. Then we have the apprentice I call Sam, the rusher. Sam works incredibly fast, writing down beautiful algebraic lines and perfectly calculated numbers, but completely forgets the core written evaluative context demanded by the question's command words. It's like baking a beautiful cake and forgetting the sugar. Today, we are going to break down both of these flawed approaches, strip your methodology down to the raw ingredients, and rebuild it so you can secure maximum marks. As a subject specialist, I'm going to show you exactly what examiners look for because we operate with a completely unforgiving benchmark in mind. When you write your statistical essay or evaluate a dataset, you aren't just solving a math problem in a vacuum. You are being actively tracked on our Michelin dashboard of assessment objectives, AO1, AO2, and AO3. And let me make this absolutely clear. Cambridge prioritizes analytical depth over superficial breadth every single time. Simply memorizing a formula, walking into the exam hall, and slapping it onto the page like a raw piece of meat won't secure you those top-tier marks. The examiner is looking for logical, structured, highly refined reasoning. If you think you can bypass the rigorous evaluation process and just jump to the final numeric answer, your response will simply taste sour to the examiner, and it will not make the cut. You have to prove you know why the ingredients work together. So, I have to ask, why is the distinction between key terminology in this specific topic so incredibly hard for people to grasp? Honestly, it is the #1 question asked by candidates worldwide, and the answer is actually pretty straightforward. Often, students, like our apprentice Alex, treat the true population mean and the sample mean as the exact same ingredient. They are not. Or students like Sam rush through the dense word problem just to jam numbers into a calculator without ever checking the real-world context of the data. The real challenge, the real heat in the kitchen here, is that sampling and estimation is the exact point where pure abstract algebra collides with harsh real-world context. You are literally bridging the gap between a massive theoretical population that you can never fully measure and a tiny, imperfect sample that you hold in your hands. When a Cambridge question drops a command word like explain, justify, or state with a reason, they are vigorously testing whether you actually understand the structural architecture of the statistics or if you're just blindly following a recipe you barely understand. Here is our strict, time-blocked structural blueprint for today's audit. 1. Mastering the sampling framework. 2. Cross-topic causal relationships. 3. The strict formatting rules. 4. Deconstruct, solve, evaluate. And finally, 5. The top 3 examiner warnings pulled directly from the principal examiner reports. We have a lot of ground to cover, so let's jump straight into the prep work. Section 1. Mastering the sampling framework. Let's look at the raw ingredients you need to get started. The foundational equations of this entire topic are absolutely key. You have to know these cold. The expected value of the sample mean, E of x bar equals mu. And the variance of the sample mean, var of x bar equals sigma squared divided by n. Now, I see this all the time. A common mistake in the exam hall is just writing these down repeatedly in the margins, hoping for some stray memorization marks. Or worse, plugging the numbers in but completely forgetting to square root that variance to find the standard error when you go to standardize your data. Both of those approaches instantly fail the test. They are totally undercooked. Cambridge demands conceptual depth here. I want you to ask yourself, what does n really represent in that denominator? It's your sample size. As your sample size n gets larger and larger, what happens mathematically? That variance shrinks. The spread of your sample means gets tighter and tighter and tighter around the true population mean. That is literally the entire theoretical foundation of sampling. It's beautiful when you actually see it. Examiners are desperately looking to see that you understand that the sample mean is itself a random variable, living and breathing with its own distinct distribution. If you don't grasp that, you're cooking blind. Section 2. Cross-topic causal relationships.
This is where we start combining flavors from across the entire syllabus.
Listen to me carefully here, because the principal examiner reports explicitly state this every single year. Candidates who actively reference cross-topic connections achieve significantly higher marks. Sampling and estimation does not live in a vacuum. It is fundamentally tethered to your knowledge of the normal distribution from earlier in the syllabus, and it is heavily tethered to your overarching understanding of probability. When a high-tariff question asks you about a sample mean, you have to instantly, almost reflexively, pull in your knowledge of standardizing normal variables. You have to know exactly how to calculate that z-score. If you try to isolate topic 6.4 in your brain and memorize it on its own, you will completely struggle when the pressure is on. Why? Because when the exam throws a curveball and asks you to use this specific variance to conduct a full hypothesis test, which is another huge cross-topic connection, if your theoretical architecture is weak, the entire response collapses like a bad soufflé. You have to link precise mathematical definitions to entirely unfamiliar contexts, rather than just reciting isolated facts you crammed the night before.
Section 3, the strict formatting rules. We are moving to the technical methodology now, how your paper actually looks on the desk. All right, let's step up to the pass line. We need to look at how a response must actually present on the physical page to secure those high tariff marks. Imagine a real heavy 7-mark pass paper question that asks you to find a specific probability and then commands you to justify your method. I literally just watched our apprentices, Alex and Sam, argue over this exact paragraph in a simulated timeline. On the left side, we have Alex's response. It is a raw, descriptive text block. It just says, I use CLT because n is large. Probability is 0.84. Alex looks at me and says, but the math is right. And I have to take my red pen and slash right through it. This response is fundamentally flawed. Why? Because it completely lacks any real evaluation. It tastes completely sour to an examiner. It gets a flat 0 for assessment objective 3. A basic descriptive sentence is not an evaluative argument. Now look at the right side. This is the Michelin star response we forced Sam to rebuild line by line. The parent population distribution is unknown. However, because the sample size n equals 50 is strictly greater than 30, the central limit theorem can be applied to assume the sample mean, x bar, is approximately normally distributed. Do you see the stunning difference in precision? It doesn't lazily say n is large, it gives the exact mathematical threshold, strictly greater than 30. It doesn't just casually say used CLT, it justifies the usage by stating because the parent population was unknown. And crucially, the absolute gold dust word here, it states the sample mean is approximately normally distributed. Every single one of those adjectives is explicitly searched for by the examiner. If they aren't on the page, the marks aren't in your score.
Kitchen freeze. Stop whatever you are doing and look right at me. Missing a specific command word or failing to provide the exact contextual justification in these multi-part statistics questions can cost you up to 60% of the available mark yield instantly. 60%. Just gone because you rushed the formatting. You simply cannot afford to skip past the terminology. Precision in this kitchen is entirely non-negotiable. And before we unlock the rest of this 5-star paragraph structure to completely transform your final grades, you need to optimize your revision recipe. Take a single second right now to subscribe to Ace the Exams at the handle @AceTheExams. Hit that notification bell so you never ever miss our weekly grade makeovers, whether you are cooking up results at IGCSE, O-levels, or AS and A-levels. Section 4. Deconstruct, solve, evaluate. Let's look at the ultimate examiner-approved step-by-step matrix. This right here is your recipe accelerator. This is the procedural framework for systematically tearing down and perfectly answering those massive, intimidating, high-tariff questions. Let's walk through this matrix using a classic Cambridge scenario, a factory producing steel cables. Step 1. Identify given info. What does the population mean? Mu. What is the standard deviation? Sigma. What is the exact sample size? N. Don't just hold them in your head. Extract them and write them down clearly with proper notation. Step 2. Break into steps. Ask yourself, are they asking for the probability of a single individual cable snapping or the probability of the mean of a whole sample of cable snapping? This one distinction dictates whether you use standard sigma or if you have to use the standard error, sigma over root n. Step 3. Solve systematically, showing every line of working. Step 4. Check for reasonableness. This is your taste test. If you calculate a z-score and it comes out to 12, you have absolutely messed up the variance formula. A z-score of 12 is practically off the known universe of the normal distribution. Finally, step 5, make justified recommendations. This is where you deploy the Peel structure, point, evidence, evaluation, link. You write that perfectly balanced paragraph we just analyzed, flawlessly blending your hard numeric facts with your final evaluation of why the normal approximation is completely valid in the context of this specific factory's steel cables. Let's break down exactly how you climb the assessment tier shown here, moving from a failing grade to absolute perfection. At the very bottom, we have descriptive. This is just identifying data.
the mean is 5, the sample size is 40. It's incredibly basic, it's just reading the prompt back to the examiner. In the middle, we have analytical. This is where you start interpreting relationships. Because n is 40, the variance of the sample mean decreases. Okay, that's better. You are starting to cook, but it's still lacking that final undeniable punch. Now, at the very top, the highest scoring tier, we have evaluative. This is where you question assumptions and justify every single decision with hard mathematical evidence. You write, since the original distribution of cable strengths is explicitly stated to be skewed and not normal, we must rely on the central limit theorem. With a robust sample size of n equals 40, which is greater than 30, the distribution of the sample mean is approximately normal, allowing us to confidently calculate this probability. Boom! That is a flawless layout. That is exactly how you secure every single mark available on the paper. Section 5, Top 3 Examiner Warnings. We are shifting into the final audit phase. I am handing control over to you right now for an interactive viewer taste test arena. We are looking directly at the 3 most common sour ingredients that absolutely ruin exam papers, pulled straight from the examiner reports: missing proper format, failing to check presentation, and answers not specific to context. I am going to give you a mental 60-second timer right now. I want you to spot the poisoned sentence in this flawed logic string from a real past paper. Ready? The student wrote, the sample mean variance is 15/50, so probability is p of z less than 1.2. Look closely at that. Where is the discrepancy? Have you spotted it? The student correctly identified the variance of the sample mean as 15/50. That part is fine. But when they went to calculate the z-score to get 1.2, they divided by 15/50 instead of dividing by the square root of 15/50. They totally forgot to convert their variance back into standard error before standardizing. This is a massive, catastrophic presentation failure. And to make it worse, they provided absolutely zero context. Writing p of z less than 1.2 means absolutely nothing to an examiner without a concluding sentence saying, therefore, the probability that the average weight of the 50 apples is less than x is 0.8849. You have got to tie the naked math back to the actual apples or cables or whatever the question is about.
And that leads right into this massive examiner alert. I cannot stress this enough. Examiners frequently, aggressively note that students lose marks by simply not showing they're working. This brings us to the method mark strategy. Look, if you are like our apprentice Sam, and you try to do complex, multi-layered fractions entirely inside your calculator to save time, and your finger slips and you make one tiny typo, your final answer is completely wrong, and you get exactly 0 marks for that section. But if you write out the entire standardized formula on the page, with all your numbers substituted in perfectly, writing z equals x bar minus mu all over sigma divided by root n, the examiner sees your entire thought process. Even if your final calculator output is totally ruined, you secure the method marks. Proving your exact process is essential, and quite frankly, in the eyes of the board, it is often far more important than just having the correct final numeric answer.
To lock in all of this rigorous high-level terminology, you need to mentally build a mnemonic for the central limit theorem requirements right now. Think of it as your kitchen prep list, something like PUNLN, parent unknown, n large, approximately normal. Say it out loud, write it on your mirror, whatever helps you burn it into your memory. As we close this audit, I want to distill today's entire session into 3 universal, unbreakable rules. Rule 1, the 3-step ingredient prep. Always decode your parameters clearly on the page. Identify mu, identify sigma squared, and identify n before doing anything else. Rule 2, the heat control formula. Standardize incredibly carefully and never forget to take the square root of the variance for your denominator. And Rule 3, the pass line review checklist. Always ensure you have evaluated the raw math within the specific, real-world context of the word problem and explicitly justified your assumed distributions using precise language.
You now have the ultimate framework to completely structure your answers for Topic 6.4 and extract absolutely every possible mark from the examiner's rigorous rubric. But remember, statistical sampling and estimation goes so far beyond just beating Cambridge exam papers. This is the exact math that dictates everything from massive medical trials to global economic predictions. So I am going to leave you with this final, provocative thought. If the central limit theorem strictly requires a sample size greater than 30 to safely assume normality, how much confidence can we truly place in critical, real-world scientific studies that are forced to operate with much smaller, heavily restricted datasets? Keep your critical reasoning sharp. Make sure you hit subscribe, click the notification bell for more weekly masterclasses, and drop a comment below telling me exactly which Cambridge subject and level you are preparing to conquer next. I'll see you in the next explainer.